So in example 2, we are going to see our first example where we are constructing and interpreting a confidence interval for a population proportion P. We're being asked to use the data from example 1 to construct and interpret a 95% confidence interval for the population proportion of adults who use Facebook. Back in example 1, we had found that P hat, our sample proportion or point estimate, was equal to 0.68. We did that back in example 1 by dividing x by n right here. So we already have our P hat. I'm going to go ahead and find Q hat. We do know that if P hat is equal to 0.68, that Q hat is equal to 1 minus 0.68, which gives us that our Q hat is 0.32. Now that we have both P hat and Q hat, we do need to go and check that n times P hat is greater than or equal to 5, and that n times Q hat is greater than or equal to 5. Back from example 1, I'm scrolling back up so we can make sure we're using the correct n value. There were 1,550 U.S. adults included in that survey. That was our n value, so I'm going to use that down here. So I'm checking that 1,550 multiplied by P, which is 0.68. I want to make sure that that is greater than or equal to 5. That comes out to be 1,054. And that is greater than or equal to 5. And then I'm also going to check that n times q, so that's 1,550 multiplied by 0.32, which comes out to be 496. That is also greater than or equal to 5. So both of these conditions are true, which is very good because now that means that we can go and use the formula for the error E, which is equal to z sub c multiplied by the square root of p hat times q hat all divided by n. The critical value that we will be using depends on the fact that we have a 95% confidence interval. So I'm going to scroll over to my table of critical values over here, and I can see that with 95% confidence, our critical value is 1.96. So I will be using 1.96 for our z sub c value in this error formula. And then I will be multiplying that by the square root of p hat, which is 0.68, multiplied by q hat, which is 0.32, and then all of that is divided by n, which is 1,550. That's information that we got back from example 1. So this comes out to give us an error of about 0.023. Please do make sure that when you punch that in your calculator, you are getting the same thing that I got, so that you know that you're putting it in the calculator correctly. Now that we have the error, we're able to find the left endpoints and the right endpoints of our confidence interval. The left endpoint we would find by taking the sample proportion, p hat, and subtracting the error E. So the left endpoint is equal to 0.68 minus 0.023, which comes out to give us a left endpoint of 0.657. Now that we have the left endpoint, let's go on to find the right endpoint. We find the right endpoint by taking the sample proportion of p hat and adding the margin of error E. So we have 0.68 plus 0.023, which gives us a right endpoint of 0.703. So now I can say that our confidence interval is from 0.657, the left endpoint, to 0.703. And now let us give an interpretation of that confidence interval. The interpretation is, of course, going to start off with 95% confidence because that was the level of confidence that we were working with in this problem. So I have started off my interpretation with 95% confidence. So what can one say? So what are we talking about here? We're talking about the population proportion of U.S. adults who use Facebook. The population proportion, we do have to make sure that we have that word population in there. So we can say that that population proportion is between our left endpoint and our right endpoint. That is our interpretation for this confidence interval. So now I want you all to try to do the same thing with this same example, but this time only working with a 90% level of confidence. So the only thing that should be changing is it should change what critical value you use. You should not be using 1.96 anymore, because you will need to go over to the standard normal table and see, well, what critical value should I be using if I want a 90% level of confidence? And you'll try that example on the next slide.